So here we are with the second problem of the coplanar force system. A force of 500 Newton is applied to a point A of a L-shaped plate. Okay, this is the L-shaped plate. Find the equivalent force couple system at B. They are asking you to find the equivalent force couple system at B. Okay, so this will be the sketch given in the question itself. So you need to note down what all data has been given. That is, the distance between point B to the center of this plane will be like 0.5, and the force 500 Newton is making an angle of 60 degrees with the horizontal. So when you resolve that, you will be having these two forces, that is one horizontal and one vertical, depending upon the direction along which the force has been made. So I have resolved the forces into this. Okay, now next, the resultant will be 500 Newton acting at an angle 60 degree. Since there is only one force at A, taking moment about B. Okay, now let's take moment about B. Since there is only one force, so we need not do much about it. So you can directly go and find the moment at point B. Okay, so taking moment about B. Now what will be the effect of the resolved components at point B? That's what we are supposed to find now. So this 500, when it rotates about point B, how does it rotate? See the direction, it is rotating in clockwise direction. Okay, it is rotating in clockwise direction about point B. So 500 sine 60 into 1. So this is the distance it is going to make with the point B. Okay, when you take this line of action, so the line of action will be in this direction, 500 sine 60. So this will be the perpendicular distance of point B. Now you can consider this point B acting as here. Okay, so this will be the perpendicular distance which 500 sine 60 will be making with the point B. So into 1 minus 500 cos 60. Okay, now this is this force, horizontal force. So 500 sine 60 will be acting anti-clockwise about point B. Can you see this? Acting in anti-clockwise. You can see the cursor. Fine. Into 0.5. How did I say that? You just take, this is the line of action of 500 sine 60. Now this will be the perpendicular distance of this force. When you take this line of action of 500 sine 60, you can see the perpendicular distance will be 0.5 about point B. Okay, now that's what I have written here. So when you calculate this, you'll be having summation of MB is equals to 308 kilonewton meter, which is clockwise. If you are getting sign as positive, answer as positive, then it means that it is acting clockwise. Next. So this is our third problem. Replace the force and the couple system by an equivalent force and moment at O. Okay, this will be the sketch given in the question. So what is this? You need to first understand what is this kind of force. We have not seen an explanation. So this is nothing but, this is the lever arm, this is A, and this is F and F. So you might have understood by now. So it is a couple. Okay, so the couple value will be how much? What is the moment of a couple? Any one of the force into its perpendicular distance. That is what I have done here. Any one of the force into its perpendicular distance, that is 100 Newton meter. So this is the indication. This is the way you are supposed to provide the notify it in the sketch. Okay, this is the notation for the couple. So it is acting in which direction? See, it is rotating in, you just see this is rotating in clockwise direction. Hence I have given a clockwise rotational direction of the arrow mark. So this will be 100 Newton meter with the couple value. Okay, this is the next sketch you are supposed to draw. Fine. Next, here 50 Newton is the force constituting a couple of 50 into 2, that is 100 Newton meter. Resolving forces vertically now. Okay, before that there is an inclined force of 75 which is making an angle of 45 degrees with the horizontal. So when you resolve this, you will be having 75 sine 45 and 75 cos 45. Fine, this is making an angle theta, that is 45 degrees with the horizontal, hence vertical component will be sine, horizontal component will be cos. That is what I have written here also. Fine. When you do that, you will get resolving forces vertically, sigma v is equals to. Now what are all the vertical forces you have? You have two vertical forces, that is the vertical component of this inclined force 75 sine 45 is our vertical component, that is one force. Another force is 30 newtons which is acting downwards at point A. Okay, so now let us see how you can consider them. Sigma v is equal to 75 sine 45, this is plus because it is acting upwards, and minus 30 because it is acting downwards, and the total answer will be 23.03 newtons. This is case 1, right? Consider this point number 1. Resolving forces horizontally. Now let's see how many horizontal forces are there with you. there is only one horizontal force, okay, which is because of this inclined force, and the horizontal component of the inclined force 75. So that's what I have written. Sigma h is equal to 75 cos 45, 53.03 newtons. So after that, third step will be resultant. Your resultant will be R is equal to root of sigma h square plus sigma b square. That is, you need to square them inside and then take the square root of it. So you'll get R is equal to 57.82. Okay, now next, let theta be the angle made by the resultant. Now you need to know this resultant is acting in which quadrant. Okay, this theta is acting in which quadrant. So at what point they have asked you? They have asked at point O. So at point O, you have a quadrant here. See, this is vertical quadrant, this is horizontal quadrant. That is what I have drawn here. This is point O itself. Okay, the point, this is O. Now, how did I say this is acting in this quadrant? Now, which is this quadrant? You must understand. This is first quadrant, this is second, this is third, and this is fourth. Okay, how did I finalize that it is acting in first quadrant? We'll see it. Let theta be the angle made by the resultant. Tan theta is equal to sigma b. Okay, summation of vertical forces divided by summation of horizontal forces is equals to, what is the vertical forces? 23.03. Okay, horizontal is 53.03. So when you calculate it, theta will be tan inverse of whatever value you get out of this, and theta will be 23.48 degrees. So I have provided that notation here. How did I finalize that? Like, it is acting in first quadrant. See, you have both the values positive. Okay, in first quadrant, both x and y are positive. Here x represents horizontal, y represents vertical force. Okay, x represents horizontal and y represents vertical force. So in first quadrant, both x and y will be positive. Okay, so I have represented the resultant acting in the first quadrant, making an angle 23.48 with the horizontal. Now here I have shown the clear representation of the quadrants. This is first, second, third, and fourth. This is HV, 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 HV. So this is horizontal and vertical. You have to look upon what is your summation of the horizontal forces. Depending upon the sign, you have to finalize to which quadrant your resultant is going to lie. Okay. You are now, as per our previous problem, the resultant was lying in first quadrant because of both the sigma h and sigma v were positive. That is, summation of vertical force and summation of horizontal forces were positive. Hence, I prescribed it as like it was belonging to quadrant 1. Okay, that is what I have shown. Now next step will be taking moment of all the forces about point O. Now if you take all the forces about point O and calculate, now how you are going to calculate the moment? Now taking moment about O, that is sigma, summation of MO is equal to, okay, now what will be the moment because of 75 cos 45 at point O? There won't be any moment because of this 75 cos 45, because see the line of action, this force is passing through point O. Okay, there won't be any perpendicular distance, hence the moment because of this force will be 0. Fine, there will be no moment because of 75 cos 45, because there won't be any perpendicular distance made about point O, because the force is passing exactly on point O. Fine, so you are left with how many? You are left with one couple. Okay, you might say couple is also acting at point O. No, couple you have to consider. Okay, that is a rotation acting at any point of the body. You have to consider that moment. Fine, and also the vertical force here, it is, that is 75 sine 45. Okay, which is acting upwards, and you have one more force 30 newtons which is acting downward. So this has perpendicular distance of 4, and 75 sine 45 has a perpendicular distance of 2. Now let's see, minus 75 sine 45. Okay, now this force is rotating in anti-clockwise direction, hence I have taken it as minus. Okay, this force is acting anti-clockwise, hence it is minus 75 sine 45 into 2. The distance I was speaking, that's the perpendicular distance made by this force. Okay, minus 30 into 4. You have 30 into 4. How it is rotating? It is rotating in, again, anti-clockwise direction. This 30 is rotating in anti-clockwise direction about point O. About this point, it is rotating anti-clockwise direction. Hence, minus 30 into 4 plus 100. Since the couple is acting clockwise, hence we have to take it in a positive way, because clockwise is positive and anti-clockwise is negative. Plus 100 will give you the final minus 126.07 kilonewton meter. The minus indicates anti-clockwise. Okay, the negative sign of the final answer indicates the anti-clockwise rotation of force. Thank you, and do subscribe to my channel for more videos.